Polynomial review for precal. This note at the top is just kind of reiterating all of the things we've talked about with polynomials and that you're expected to know. Things you've been asked in your practice, we've gone over in the notes, and you've been quizzed on. You have to be able to identify all sorts of key features, either from a graph or from an equation, depending on what it is. We need to know domain and range. We need to know increasing and decreasing intervals. Extrema, that's our maximums and minimums. We need to know what's relative, what's absolute. We need to be able to find the roots or the zeros, both in factored or unfactored form of the equation, or from a graph. And we need to be able to state how many possible zeros and turning points there are given the equation. We need to be able to identify the multiplicity of those zeros and determine the end behavior using limit notation. And then we need to be able to sketch or match or find the graph given an equation. Last but not least, state or determine if it's an odd or even function. Okay, so we're going to kind of go through all of that in this review. We'll kind of see how long the videos are going and how many chunks it'll be broken up into. I'm not sure right now since we're just starting. These first four, give an equation. The first two, my pen not. Strange. Give me 1 sec. I'm going to try and switch my window over. My pen to work. Okay. Okay. All right, so what we're looking at when we have the polynomial, this is in unfactored form, you're looking for your leading term. Okay, so that is the whole term. That's the coefficient and the variable and the exponent, the power all together. It's not necessarily the term that's in front. If it's written in standard form, it would be in front, but sometimes it's not. Like you can see here, there's a squared, a cubed, and a fifth power. So that's not written in descending order, which is standard. So you're looking for the highest exponent term, which in this case is that 5 is the highest exponent. So the term is this entire thing. Okay, so that's your leading term. And then the leading coefficient is the number in front. Okay, so that is just -2. And then the degree is the exponent, the power of that leading term, that highest exponent. So in this case, it's 5. Now, when we are getting our end behavior of polynomials, we want to know, is the degree even or odd? In this case, it's odd. And we want to know, is the coefficient, the leading coefficient, positive or negative? In this case, it's negative. So remember, if you are, sketch this up here. If it is an odd degree, I want you to picture your cubic function, which looks like this. It actually goes through the origin. I kind of missed the origin there. Let me try that again. Ooh, still did. Slightly. Oh, that's a little better. Okay, so if it's odd, I want you to picture x cubed, which looks like this. But if it's negative, and odd, that has to be reflected. So you would picture it going this way. It's flipped over. If your degree is even, I'm going to put degree in front of that because we're not talking about the function is odd or even right now. We're talking about the degree is odd or even. So the degree is even. I want you to picture x squared, which you should know is your parabola. But if there's a negative in front of that, it flips it over. It's going down instead. So all polynomials and behavior are going to follow one of those four. They're going to be going in opposite directions on the left and the right if it's odd degree. They're going to be going in the same direction, either both up or both down, if it's an even degree. Okay, so in this case, this is odd and negative. So it's this one we're picturing. We don't know what's happening in the middle, but we know the left side will be going up and the right side will be going down. So I know this is the general shape of the ends. Now, limit notation, where did it say that up here? Use limit notation. That's where we need to be able to say that the limit as x approaches infinity, that means the right side, because x goes to infinity as we go right, the function, and actually this one is not called f of x, they just called it y, so I'll just use y. They just said y equals. If it said f of x equals, or h of x equals, or g of x equals, that's what would go here. So as x approaches infinity, y is going, so the right side is going down. So it's going to negative infinity. And then the limit as x approaches negative infinity, that means left. Because as we go left, x is going towards the negatives. Y goes toward, you can see the left side is going up. So it's going to positive infinity. So the leading term, we pick out the degree and the leading coefficient and use that to get our end behavior. Now in the middle, this question is asking about how many possible real zeros and how many possible turning points. That all comes from that degree as well. So the number of possible zeros is n. That's your degree. So if it's a fifth power, that means you could have up to 5 possible zeros. Doesn't mean you guaranteed will. You could have less than that. Some could be imaginary or some can be repeated, but you could have up to 5. And then the number of possible turning points, like when the graph changes direction, so creating an extrema, a maximum or a minimum, is 1 less than that. So there are 4 possible turning points. So let's try and go through that a little faster with this second one. So our leading term, the highest exponent here is also the 5th power. So it's the positive 7x to the 5th. So the degree is 5, which is odd. And the leading coefficient is positive 7. So we said that's positive. So I know my end behavior, if it's odd and positive, I'm picturing this one here, it's going to go up on the right and down on the left. So this would be the limit as x approaches positive infinity, that's the right side. Y is going to positive infinity as well. So the right side's going up. The limit as x approaches negative infinity, that's the left side. Y is going down. It was 5, so that's the possible number of zeros. And so the possible number of turning points is 4, 1 less than that. All right, the next 2 are asking for similar things, but they are in factored form already. So we have to kind of think. We have to think, okay, x cubed is not my degree because here's another x and here's another x squared. Those all have to get multiplied out by each other, before we would know what that leading term would be in standard form up here. So I just have to imagine, I know that all of these would eventually get multiplied by each other. I could distribute the x cubed here first, and then I could FOIL out the two binomials, but I don't actually have to do all the terms. I'm only worried about that lead term. So the x cubed times x would be x to the fourth times x squared would be x to the sixth. And none of them have a coefficient. It's a 1, a 1, a 1. So 1 times 1 times 1 is still an understood 1. So there's my leading term. The degree is the 6, and the coefficient is an understood 1. So that is positive and even. So that means that my end behavior, positive, I'm thinking of quadratic. Positive even, I'm thinking of a quadratic, a parabola opening up. So that would be written as the limit as x approaches infinity, y approaches infinity. And the limit as x approaches negative infinity, y approaches infinity. So both sides are y is going up to positive infinity. Now the possible number of zeros is 6, because that's the degree. And so there would be 5 possible turning points. Now something extra that this one asks about that the others didn't is, what are the zeros and what is their multiplicity? So the zeros, once it's in factored form, I can just set each of these factors equal to 0 and solve. Well, if I set x cubed equal to 0, I would take the cube root of 0, it's still 0. So there's a 0 or a root or a solution or an x-intercept, however you want to think of it, at 0. Okay, if I set x plus 1 equal to 0, I would have to subtract the 1 over. So I would end up with -1. And then if I set this one equal to 0, I would add the 4 over and then take the square root. And square root of 4 is positive or -2. So positive or -2. You can write it like this, or you could write 2, -2 and list it out separately. So this one has 4 zeros. It could have possibly had up to 6, but it only has 4. Now, why might that be? Look at the multiplicity. So here, this factor is not raised to a power. It's an understood power of 1. This factor, the x was squared, but that's when we solved it. That's why we got plus or minus. We got 2 solutions because we got rid of the square. But this one, this factor, x, is cubed. That means it has a multiplicity of 3. So the 0 has a multiplicity of 3, which what that tells us is in the graph, if it's got an odd multiplicity, it's going to pass through the x-axis. It's actually going to cross at that 0. If it had an even multiplicity, then it would bounce off of the x-intercept. It wouldn't cross over from positive to negative or negative to positive. All of these happen to have an odd multiplicity, because even these that don't have any, that's a 1. A 1 is an odd number. Okay, so you can write that out. This one had the multiplicity of 3. The rest of those all have a multiplicity of 1. So all of them are odd multiplicities, which means they all cross. The x-axis. So if I was asked to sketch this, which I wasn't, but let me just, this might help you visualize that multiplicity rule. I have a 0 at 0, at -1, at -2, and at +2. So those are my 4 zeros. And I know my end behavior, it's going up on the left, and it's going up on the right. I don't know exactly what's going on in the middle, but based on this, and the multiplicity that it actually has to cross at all of these. So none of these are just going to bounce off and come back up. It's actually going to cross the x-axis here. So somewhere between these, it's going to have to turn and change directions to cross again. It's going to have to turn and change directions to cross again. It's going to have to turn and change directions to cross again. So our graph is going to have three relative extrema. One of these is going to be absolute. I don't know which one it is without doing more work. I just kind of made that up. But I know that it has to cross over at each of those intercepts based on the odd multiplicity. All right, on number 4, if I were going to multiply, again, this is a 1x, a 1x, a 1x. So if I were to multiply all those out, I would end up with x cubed. So the degree is the 3, which tells me the possible number of zeros is 3. The leading coefficient is a 1. So again, that is a positive, and this time it's an odd and positive. So I know my end behavior here, odd and positive. I just picture a cubic like this. So the limit as x approaches infinity, that's the right side, is going up to infinity. And the limit as x approaches negative infinity, that's the left side, y is approaching negative infinity. So it's the right is going up, the left is going down. The possible number of turning points is always 1 less than the possible number of zeros, 1 less than the degree, so 2. Now, what are those zeros? Well, let's take a look. It's all factored. If I set this equal to 0, that's just 0. If I set this equal to 0 and solve, I'd get -1. If I set this one equal to 0 and solved, I'd get +3. None of those have a power on them. So that none of those have any multiplicity over 1. So multiplicity of 1 for all of them, which means it's going to cross at all of those because 1 is an odd number. So if you were going to sketch this, I would say there's a 0 here at -1 and at +3. And I know that the left side is falling and the right side is rising. And I know it's going to cross at all of these. It's going to come through. It's going to turn somewhere and come through, turn somewhere and come back through. So something like that. There will be 2 extrema in that function. All right, let's look at number 5. It says, which of the following terms, when added to the given polynomial, will change the end behavior? So again, what affects the end behavior is the leading term. So I just need to know, would anything change the leading term from right now? It is negative coefficient odd power. So right now it's negative coefficient odd power or odd degree, whatever you want to call that. So if I were to tack any of these on and combine like terms, would that change? So if I were to put minus x to the 8th, yeah, that 7 is no longer the highest degree. This is, and now it would be negative even. So that would change the end behavior for sure. Okay, what if I tacked on minus 3x to the 5th? 5 is less than 7, so it doesn't change the leading term, so it does not affect the end behavior, so no. What if I tacked on plus 5x to the 7th? Well, that's the same, so I need to combine like terms. So -2 plus 5 would be +3, so that would change my coefficient from negative to positive. So yes, that would change my end behavior. If I tacked on a constant, neither of these have an x, that's not going to affect my end behavior because it won't change this leading term. So only those two would change the end behavior. All right, in number 6, we are given a graph of a quartic polynomial. They're calling it f of x. They want us to determine the number of x-intercepts. Okay, so x-intercepts are how many times it actually touches the x-axis. So there are 3 of those. Determine the number of relative minima. So relative minimum are low points relative to the points around them. So this is a low point relative to the points around it. It's like the valley. This is a low point relative to the points around it. It's a valley. So there are 2 relative minima. The number of relative maxima. So maxima is high points, peaks, points that are maximums relative to the points around them. So here is 1. That's it. There's only 1. Absolute minimum, A. Well, that's what we want to label the absolute. So absolute is the relative minimum that is not just a minimum relative to the points around it, but it is absolutely the lowest the graph gets anywhere. Let me get a different color for that. So out of these 2 relative minimum, this one is not the lowest on the graph, but this one is. It is absolutely the lowest point on the graph. So we're going to label that as A. Absolute minimum. Now explain why the value does, if it does not exist. It does, so we don't need to worry about that. That's if you didn't have an absolute. You don't have to have an absolute. So for E, it says label the absolute maximum. Well, out of my relative maximums, this is not the absolute maximum. This graph continues on the left and the right to go up forever. So this one, there is no absolute maximum. I'm going to explain why, and that's because the graph increases to infinity, goes up forever, however you want to word that. Okay. You could say the end behavior, both the left and right are rising, or you could write it in limit notation. You could say the limit as x approaches infinity, f of x approaches infinity. So if f of x is going to infinity or negative infinity, then that means there won't be an absolute maximum, or if it was negative infinity, there wouldn't be an absolute minimum. So that's my explanation. On 7, we have a graph of a 6th degree polynomial, g of x. They want us to identify all the zeros and state their multiplicity. Okay, so here's the zeros. Okay, so here's the difference I was trying to explain earlier. Notice how this one, it doesn't cross the axis. It bounces off, it turns. That means it has even multiplicity. So at -3, 0, there is even multiplicity. And then at 2, it crosses. It's a point of inflection there. It doesn't change direction though. And then at 4, it crosses. It doesn't change direction here. So at 2, 0, and at 4, 0, there is odd multiplicity. Now, to get more specific than even or odd, we have to know the degree of the function, which we do. They told us it's a 6th degree. So that means we know that there's 6 possible zeros. Now, they may not all be real, which they're obviously not here because I only see 3 real zeros. But the multiplicity here is even. remember the number of turning points. It turns 1, 2, turns 3 times. So the degree has to be at least 4, which it is, it's 6. So I'm actually not going to have, y'all don't have to get more specific than that, just knowing that this should be even. So that could be a 2, it could be a 4. And then these have to be odd, so they could be like 1s or 3s. Like if this was a 2, a 1, and a 3, that would add to 6, the degree. If I tried to make this 4, then these would both have to be 1, 5, 6, because that would have to add to the multiplicities, have to add up to that 6. All right. On 8, it says a polynomial has a 0 at 4, which is a multiplicity of 2, at -2, and at 0. What's the minimum degree of the polynomial? So I'm going to sketch this to give you a visual. So at 4 and at -2 and at 0. Okay, and this one has a multiplicity of 2. So it's going to bounce off this one and it's going to cross at these. Now, we don't know the direction of the end behavior or anything like that, so we can just pretend and say, well, we know it has to cross at these, so it's got to turn there, and then it's got to come back to this one, but it can't cross, so it has to turn again and come back down if we started this direction. So essentially what that means is that there has to be 1, 2, and then this itself, 3 turning points. Okay. And there is, what is the minimum degree of the polynomial? So that's got a multiplicity of 2, 3, 4. So the minimum degree is 4. Write an equation for the polynomial in factored form. So it could be the 4 would have to be x minus 4, because remember when you set it equal to 0 and solve, you want it to come out to +4, so it's the opposite sign in here. Multiplicity of 2 means that factor is squared. And then this one is minus, it's -2, so minus -2 would be +2. And then for it to be 0, that just means there's nothing added or subtracted to it. It could just be an x. Okay. It could be a 2x, a 3x, a 4x. That doesn't matter. Or the x could be in front instead of at the end. It doesn't matter. That comes out the same. The way that I drew this, I drew it opening down, so that would mean that there was a negative out here, but it didn't have to be drawn down. I could have drawn that the other way. But they're not asking about that. There's more than one correct answer here, but that's an equation that would represent a polynomial with a 0 at 4, with a multiplicity of 2, a 0 at -2, and a 0 at 0. All right, let's do number 9 here, and then I'll stop this video, and then I'll do the rest of the review on a separate video. So on this one, we're given partially factored form. We have one of the factors, x plus 6, but then here, this is not completely factored. So to find all of the zeros, I'm going to have to finish factoring this quadratic right here. So this is an understood 1. So I'm just going to use guess and check method when it's an a of 1, especially since c is prime. The only factors of 5 are 5 and 1. I know it needs to multiply to a positive and add to a positive. Oh, well, if I try to do that, look at that. That would not add to 2x. So that one is not going to factor. That's why they didn't finish factoring for us. All right, so to find the zeros, we know one of them has to be at -6 from that first factor. And since we can't factor this by hand, you would have to use quadratic formula. So you may or may not remember this. I'll tell you right now, you're not going to have to use quadratic formula on the test. This is the one though, if you haven't, I think I sang it for y'all to remember the quadratic formula. It's to pop goes the weasel. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So your A, B, C, A is a 1, B is a 2, and C is a 5. That's A, B, C. So if I were to plug that in, so negative B, so 2 goes there. 2 gets squared. A is an understood 1, and C is a 5. 2A is a 1. So when I go to calculate this under the radical, I'm going to get 4 minus 20. I get a negative under the radical. I'm just going to stop here. I shouldn't have put this one on here, my bad, because you get a negative under the radical. This is going to come out imaginary. We can't take the square root of a negative. We get an imaginary number, which we technically could write out the solution as an imaginary number, but we're not worried about that right now, so I'm not going to get into it. If this was factorable, you would factor and then list your other factors, but we won't get into imaginary ones. It says rewrite the equation in fully factored form. We're not going to do that because we're not bothering finding those imaginary factor or imaginary roots. So we're going to skip that. So essentially just omit 9 is what we're getting at, apparently. Okay, so I'm going to stop this video here and I'll start. If you need help on the second half of the review or the next page of the review, you can watch the next video.